This video will tell us how to get the second Suvat or motion equation, and this time we're going to use the idea of area. And if we're taking the area of a box, um, let's change our graph a little bit. Let's just say we have a second line here, and I got to select a pen, and let's just say I want to take. Let's pretend that's a straight line. I know it's not really straight, and let's just say this has some velocity v, and it happened over a time t. Well, if I took and found the area of this, area of a rectangle is just going to equal basically base times height. And in this case, it's going to be the base, which will be the time, times the height, which will be its velocity. And if we look at this from a unit standpoint, well, that's going to be in seconds, and this is going to be in meters per second. Well, those two units will cancel, and I'll just end up with meters. So what we're finding out in a velocity time graph is area is equal to the distance. So we can take this idea now and do this for the entire area. We just found this, this would be something traveling at a constant velocity. We found the area below this curve and said, whatever this is traveling, the area that this forms would be the total distance that it's traveling. So what we want to do is figure it out when it has a changing velocity. We notice that now this slope is increasing. So we're going to have to change things a little bit. What I'm going to do is undo my changes real quick to try to get back to my original graph. Okay, and now we're back to here, and I'm going to just change colors because it's like a little bit different. I want to go back to this blue. We want to know what's the area under this entire curve. And we can't really give us one big area formula, but we can definitely figure out the area of these two parts. We're going to have the area of this rectangle down here. We'll have the area of this triangle up here, and I'm trying to dotted, kind of give it a different way of shading that in. I know that's not a perfectly drawn. These should be pretty much lining up over here, but for our purposes, I think we understand what we're trying to accomplish. We already said that the area is going to equal the distance, which is s for our variables. So we're going to have s is going to equal the area of our rectangle, which will simply be base times height from what we said before, plus the area of this triangle. Well, that's 1/2 base times height. Not anything that's any more difficult. So okay, well, what's the base of this? Well, it's going to be the time. So I'm going to have time times the height, which in this case is u, the initial velocity, plus 1/2 times the base, which again is time, and this time the height. Well, this height is not as simple as it was before. It's going to be v minus u. Now that in itself is a useful equation, but we would like to have acceleration incorporated into this somehow. And one thing we want to make sure we take note, our acceleration is constant because we have a steady sloping line right here. Acceleration represents the slope of that line, and because we said from the previous video, the slope is not changing, the acceleration then is not changing. So now we want to simplify this a little bit. This is where we're going to make a substitution. From before, we said we have our Suvat was v equals u plus a times t. Well, what if we solve this for v minus u? Well, v minus u is going to equal a times t. So now we can plug this into this over here. So kind of rewriting my equation, I'm going to have s is equal to, I'm going to change the order, u times t plus 1/2 t times a t squared. There's our substitution from before. Well, a times at, I'm sorry, it's not squared right away. This is t times at, I jumped the gun. The rewriting of this is s is equal to u times t plus 1/2 a t squared. I'm so used to writing that I automatically put that on there. That's our second Suvat equation. And solve for distance. So this is very useful when we're trying to find the distance something traveled if we know the time and the initial velocity and the acceleration. Our last video, which we'll do in a second, is going to involve the third Suvat equation.